This is the Soviet Union's Venus 4 probe. Preparing for the first landing on Venus. Before this, Venus was imagined as a world. Possibly similar to Earth. Beneath its thick clouds, oceans might exist. With similar atmospheric pressure and temperature. But they had no idea that this poor artificial object was about to enter an extremely harsh environment. As it entered Venus's atmosphere, at a speed of 40,000 kilometers per hour, the parachute deployed, and the antenna began to transmit data. The initial data was exciting. The atmospheric pressure was similar to Earth. The temperature was about 30 degrees Celsius. But as the probe descended further, the readings began to change dramatically. 1 atmospheric pressure quickly turned into 10. However, unfortunately, they experienced a complete system failure before reaching the destination, and failed to return any valid data. This was a major blow to the Soviet space program. However, in 1962, America's Mariner 2 spacecraft made breakthroughs where the Soviet missions failed. Mariner 2 was only 35,000 kilometers from Venus and conducted the first close observation. The spacecraft returned a large amount of valuable data, validating Carl Sagan's theory about the greenhouse effect. Mariner 2's microwave radiometer showed that the temperature on the day side reached 237 degrees Celsius. In addition, at an altitude of 50 to 80 kilometers above the Venusian surface, there is a layer of dense clouds. Based on this data, NASA decided not to explore Venus again in the short term, believing its harsh environment was completely inhospitable to humans and machines. Thus, the exploration targets shifted to the Moon and Mars. But the Soviets did not think so. They prepared a second wave of Venus probes, although they did not yet know how difficult the upcoming challenges would be. In 1967, the Soviets built larger and sturdier spacecraft for Venus 3 and 4, weighing nearly 1 ton. Equipped with barometers, radar altimeters, gas analyzers, thermometers, and a separable descent module. The plan was for the descent module to pass through the atmosphere with a parachute, collecting data on composition, temperature, and pressure along the way. However, things were not that simple. Venus 3 again experienced a system failure during descent. The spacecraft crashed into the surface of Venus like a bullet, becoming the first man-made object to impact another planet. On June 12, 1967, Venus 4 was launched. It consisted of a mothership and a lander, the latter to descend through the Venusian atmosphere using a parachute and conduct exploration along the way. At the same time, the mothership would also plunge into the Venus atmosphere and disintegrate, similar to the approach of Venus 1 and 2. adopt the simultaneous launch of two identical probes, using quantity to exchange for a brutal method of strategy. Within a week after the launch of Venus 4, another probe identical to Venus 4 was launched. However, the latter failed to leave Earth's orbit due to rocket failure, and subsequently fell back to Earth. According to Soviet practice, to cover up the failure, they would not give it a formal name, but rather use a cover name to pass it off. Cosmos 167. After 4 months of flight, on October 18, 1967, Venus 4 successfully arrived at its destination. Subsequently, the mothership successfully released the lander to begin descent, and successfully deployed its parachute, becoming the first spacecraft to collect data in another planet's atmosphere. The Soviets realized that once entering Venus's atmosphere, time was limited, so they had to pass through before the probe could be crushed or melted by the atmospheric pressure. The transmitted data showed that just after entering the atmosphere, the temperature and pressure were very suitable, as if it were a summer day on Earth. But as the lander continued its descent, the temperature suddenly rose, and the air pressure increased instantly. The thermal shield withstood extremely high temperatures and experienced severe deceleration, exceeding 300 Gs. When the lander descended to 24 kilometers above the surface of Venus, the signal transmission suddenly interrupted. It was generally believed that the lander was crushed and destroyed by Venus's high atmospheric pressure, and the entire descent process lasted 93 minutes. But that was enough for successfully completed its mission. With these new data, the Soviets could almost confirm that the subsequent Venus 5 and 6 probes would not be able to reach the surface at all. In 1967, NASA launched another Venus flyby mission, the Mariner 5 probe. Although it did not contact Venus, the flight distance was close enough to confirm the extreme environment detected by Venus 4, verifying that Venus's conditions were harsher than initially detected in the early 1960s. In light of this, the Soviets launched Venus 5 and Venus 6 consecutively in January 1969, but undoubtedly met the same fate. These two probes encountered the same fate shortly after transmitting data for less than an hour, being crushed by Venus's high pressure. However, the Soviet Union did not give up. In order to reach the surface of Venus before being destroyed, the Soviet Union redesigned the Venus 7 probe. They added a baseband with a melting point of 200 degrees Celsius to the parachute, preventing the device from fully opening, thus allowing the lander to descend faster. Secondly, the lander was made of thicker metal, with more insulation inside, and a titanium sphere was used to protect the instruments from high temperatures, while also adding a buffer to reduce impact. The Soviets were prepared to let Venus 7 undergo a test of endurance. When the probe entered the atmosphere, it began to slow down and deployed the parachute. The inner gas belt played a role, allowing the probe to pass quickly through Venus's thick atmosphere. This time, the probe was closer to the surface than previous missions. However, when only 3 kilometers remained from the surface of Venus, the parachute suddenly ruptured, and the probe fell towards the ground at a speed of 60 kilometers per hour. The Soviets thought it was another failure, but weeks later when they reviewed the data, they found that the lander had transmitted a weak signal for 23 minutes after crashing into the surface. It turned out that the lander had actually survived, but was knocked to the side, causing the signals sent to Earth to be very weak. Incredibly, the data finally transmitted by the probe indicated that the surface temperature reached 475 degrees Celsius. This is enough to melt lead, far exceeding any temperature that machines can reliably operate at. Since the temperature became the main issue limiting the lander's survival time on the surface, the engineers designed a simple but clever cooling solution for Venus 8. They placed lithium nitrate blocks inside the probe, a salt-like substance with a high latent heat that can absorb a large amount of heat. This system was very effective. Venus 8 successfully reached Venus and survived on the surface for a full hour. The Soviets had now mastered the technology to reach the surface of Venus. But the whole world still does not know what this planet is actually like. So, Venera 9 took on the role of capturing the first photo of Venus. to take the first photo of the surface of Venus. The Soviet Union underwent a comprehensive redesign of the spacecraft. This time, they no longer relied on parachutes, but used atmospheric braking to decelerate, and equipped with a set of landing legs to absorb the impact. Venera 9's core mission is the camera system. The spacecraft is equipped with two movable cameras, located on both sides, capable of capturing a 360-degree panorama of the surrounding landscape. The cameras are placed inside the spacecraft's pressure chamber, extending through the periscope to the thick pressure window. Although only one lens covered normally, this was enough to capture the first photo of the surface of Venus. On October 20th, 1975, after 53 minutes of transmission, Venera 9 sent back the first ever photo of another planet's surface. Its rich, sharp-edged layers amazed scientists. Is there a score, especially with the same height? Always at that waveguide chamber when not COS receiving network embed indicated jet. Thank you for watching. Around the same time, its sister spacecraft Venera 10 also landed on the surface of Venus. Different from the small rock seen by Venera 9, Venera 10 captured rock plates similar to Earth's volcanic regions. 3 years later, Venera 11 and 12 were both equipped with color cameras, and both probes had a common purpose, which was to study the atmosphere of Venus, cosmic rays, and solar wind ions. On December 21st, 1978, Venera 12 detected frequent lightning over Venus during its descent, with roaring thunder. In just this period, from 11 kilometers to 5 kilometers above the surface of Venus, 1,000 lightning strikes were recorded. This also prevented the camera's color imaging function from continuing. Until 1982, when people eagerly wanted to take color photos, Venera 13 was sent. This probe astonishingly sustained itself on the surface of this distant planet for 127 minutes. In such a long period of high-speed operation, it transmitted color images back to Earth. A flat, dark, layered rock and bizarre landscape filled with pasty material unfolded before us. Just 4 days later, Venera 14 also reached the surface of Venus. But the landing site was different, and the ground was more fragmented. Unlike what Venera 13 saw, there was almost no pasty material here. The yellow sky and highly fragmented surface highlighted the harsh environment of Venus. Venera 13 and 14 not only successfully captured images of the surface of Venus, but also decoded the sounds of the neighboring planet for the first time. All probes were equipped with microphones to record the sounds of Venus. In the recordings from Venera 14, noise, the mechanical sounds of the probe drilling, and the faint sounds of Venusian winds can be heard in the background. Further analysis showed that the wind speed was about 0.3 to 0.5 meters per second. This indicates that the dense atmosphere of Venus at the surface is surprisingly calm. After this, the Soviet Union launched the Vega 1 and Vega 2 probes to Venus on December 15th and 21st, 1984, respectively. This time they on the probe loaded landing device and helium balloon, allowing gas to drift in Venus's atmosphere. Thus analyze Venus's wind speed, temperature, cloud density, atmospheric pressure, meteorological information. Once the two probes land, further determine Venus's surface crust data. Meanwhile, America's Magellan probe on August 16th, 1990 flew 250 million kilometers from Earth to investigate Venus. Every 40 minutes, returning measured data and captured photos to Earth. Through probing, people first obtained a complete map of Venus, providing visual materials for studying and understanding Venus's geological features. In November 2005, the Venus Express probe was successfully launched by the European Space Agency to Venus. This is Europe's first in-depth study of our neighboring planet. The specialty of Venus Express lies in its in-depth study of Venus's unique polar vortex. Every 24 hours flying around Venus, conducting a 486-day probe of Venus. Now, decades have passed since the Soviet Venus series probe missions, and we re-examine things beneath Venus's cloud layers. Changes may be imminent, because this region's blistering scenery is about to greet more visitors. Among them, The most exciting is NASA's Da Vinci mission. Plans to carry out 2 Venus probe missions between 2028 and 2030. The goal is to collect information on Venus's atmospheric composition, study whether there were oceans on Venus's surface, and whether it ever harbored life. During the flyby, the Da Vinci spacecraft will release a descending probe carrying a camera, allowing us to see Venus in an unprecedented way. In a descent process lasting 1 hour, the probe will make thousands of measurements, and after emerging beneath the thick cloud layers, capture close-up images of Venus's surface. However, the probe does not need or consider surviving in its landing. But if a miracle happens and it lands successfully, it could provide up to 17 minutes of valuable scientific data. A bit regrettably, the Da Vinci descent probe does not have a panoramic camera. This means the old photos of the Venus series landers may still be our best close-up shots of this hellish neighbor years later. How exactly did Venus transform from a possibly habitable planet to a dry, muggy world?